let us discuss new concept, that is limit point. Okay, so let us discuss the definition of limit point. If we have a matrix space xd, okay, I have written already that thing. So suppose this is matrix space xd. Okay, let a subset of x. So we have some subset of x which is a. Then x belongs to capital X is said to be limit point of a if for every r greater than 0. We are defining a limit point. X belongs to capital X. It is any arbitrary point of X. Is said to be limit point of this set A if for given every r greater than 0, bxr minus singleton x. What is meaning of it? Bxr, that means open ball with center x, radius r. We are removing x from it. That means we are removing center of a ball from that ball. Getting? So we can call it as a puncture disk. A center is removed from a ball, so the remaining part is called puncture disk. So such set we have intersection A should be not equal to phi. That means every open ball around x intersects A other than x. Okay, so yeah, let us see. Suppose x is this point x. So if you draw any ball around x, so that ball contains points of A other than x, therefore we can declare x is a limit point. Getting? You can draw any ball around x, small ball, large ball, doesn't matter. Any ball definitely contain points of A other than x. So that's why we can declare x is a limit point of A. Getting? So if you consider some point y here, can we say it is a limit point of A? Let us check. I will draw any ball around y. Definitely that ball contains points of A other than y. So that's why we can say y is also limit point of A. If you consider any point z here, can we say it is a limit point of A? If you draw a large ball, then it will contain points of A other than z. But if you draw a small ball around z, it does not contain any point of A other than z. So therefore we can say z is not a limit point of A. I hope all of you understood the meaning. Let us repeat. When we say x is a limit point of A, for every r, okay, in case of open set we consider there exists r greater than 0, but here for every r greater than 0, open ball where its center is removed from a ball, getting? Intersection with A is not equal to phi, non-empty, that means 100% every ball around x is intersecting A, okay, and obviously other than x. So then we say x is a limit point of A. So here A dash denotes set of all limit points of A. Sometimes we use D of A also, D of A. So that symbol also we use, or most of times we use A dash only, set of all limits points of A. And that set is called as derived set. And A dash is known as derived set. Okay, so you can make a screenshot of it and then we will discuss few examples. Let us discuss few examples. Okay, so we are considering a matrix space Rd where D is a usual distance, means D of xy is equal to mod x minus y, and we are taking first set A is equal to open interval 2 3. I will draw that interval 1 2 3 4, getting? We have an open interval 2 3, and now we will find limit points of this set. Okay, then simply I will say A dash, that means set of all limit points. Tell me, if I take any point x between 2 and 3, can we say it's a limit point? if you draw any ball around x, definitely it contains, okay, open ball that other than x contains some points of this interval 2, 3. So that means definitely x is a limit point. That means every point which lies between 2 and 3 is a limit point. Get it? What about 2? If you consider this point 2, P, can we say it is a limit point? If you draw any ball around 2, okay, so definitely other than 2, it contains some points of that interval 2 comma 3. So that's why 2 is also a limit point. So same logic we can apply for point 3 also. If I consider q is equal to point 3, if you draw any ball around open ball around 3, definitely it contains some points of interval 2, 3. So therefore 3 is also a limit point. Getting? If you consider any point outside the interval 2, 3, then if you draw any small ball around z, it does not contain any points from this interval 2, 3. So therefore any point which lies outside the set is not a limit point. Okay, if you consider the point on that side, same logic we can apply. So what is our conclusion? Every point between 2 and 3 is a limit point. 2 is also a limit point. 3 is also a limit point, but other than these points, there is no other limit point. So therefore, our conclusion is a dash is equal to close interval 2, 3. 2 is also limit point, 3 is also limit point, and a point between 2 and 3 is the all points are limit points. So a dash, say derived set is 2, 3. Let us go for the second example. B is equal to Z, set of integers. So you know that set of integers, negative integers, positive integers and 0. 0, minus 1, 1, 2, 3, 4. Getting? So let us check 1 is a limit point or not. Let us check 1 is a limit point of this set Z or not. If you draw a small ball around 1, is there any integer? Okay, so is there any integer other than 1? No. In this interval, in this open ball, there is only one integer which is 1. But you remember in definition of limit point, we remove the center of that ball. Getting? So you cannot consider 1. But other than 1, is there any integer? No. So 1 is not a limit point. If you consider point 3, is this a limit point? If you draw any ball, small ball around 3, it does not contain any integer other than 3. So therefore 3 is also not a limit point. Similarly, we can say 4 is also not limit point. Negative 0 is also not limit point. Negative numbers minus 1, minus 2, minus 3, all these are not limit points. If you consider any point between two integers p, getting? So if you draw ball around it, there is no integer in that ball. Okay, so therefore that p is also not a limit point. That means we considered all integers, these are not limit points, and if you consider any number other than integer, then that is also not a limit point. That means we do not get any limit point here. So derived set b dash, which is equal to phi, empty set. Next, c is equal to rational numbers. Getting? Then we have to find c dash, derived set. So if you consider real line 0, 1, 2, 3, can you tell me how many rational numbers between 1 and 2 or 2 and 3? Getting? So there are infinitely many rational numbers. The density theorem says between any two rationals you will find irrationals, and between any two irrational there is rational. That means there are infinitely many rationals and irrational between any two integers you can consider. Getting? So if you consider any point p, and if you find an open ball around p, that means an open interval around p, then there are infinitely many rationals getting other than p. You are getting my point? So therefore p is a limit point, because in that interval density theorem says there are infinitely many rational numbers. Getting? So therefore p is a limit point. If you consider p here, same logic we can say p is limit point. If you consider p is equal to 0, no problem. If you could draw any ball around 0, then also there are infinitely many rational numbers. So therefore 0 is also a limit point. So what I want to say, if you consider any arbitrary point, 100% it is a limit points. So therefore, derived sets, all real numbers are limit points of set Q. So therefore, derived set is R. So in this way, we have discussed these three examples. You can make a screenshot of it. After that, we will stop. Thank you. Bye-bye.